This video is on interpreting Jamovi results, and I'm going to talk about the regression equation. So if you didn't watch the previous videos on conducting the test, you might want to do that. But we are looking at we have three predictors. We have agreeableness, neuroticism, and gender. And within gender, we have, through Jamovi, it has dummy coded our gender variable, and we're predicting our outcome variable, which is Machiavellianism. So these are the results from our test. And you can see first we want to look at this overall model. If this overall model was not statistically significant, we would stop there. So first, you can see that our adjusted R squared is 0.38 or 0.39 if we round up. And then you can see that that's not that different, but the R squared unadjusted would have been 0.40. So it's adjusted a little bit down. We have our F statistic, which we'll report. We have our degrees of freedom, so we'll report that as well. And then we have our p-value. And so this is what tells us the p-value is less than 0.05, p-value is low, so we reject the HO. So we're rejecting our null hypothesis. And so the p-value tells us that the overall model is significant. So we're going to continue to look at our individual predictors. If it were not significant, we would stop here and we would just report the results that it was not significant. So next we want to look at all of these numbers down here. So many numbers. So first we can see the intercept. This is it's A in our formula, which I'll show on the next screen. So our intercept here, this is what our value, our predicted value of Machiavellianism would be if all of our X values were zero. So if agreeableness were zero, neuroticism were zero, female were zero, other were zero. Now the next one that we're going to look at is below this. So then below the intercept, we have this agreeableness total, neuroticism total, and then again, these dummy coded variables of female and other that are being compared to the reference level of male. These are the unstandardized beta weights. So this is for each of the predictors or each of the independent variables. You can see that they're all negative. Negative means that when we have more agreeableness or more neuroticism, or they're female or they're other, that means that it decreases, or that not that it decreases, because that kind of sounds like causation, but that people who are higher in those variables tend to be lower in Machiavellianism. So people who are more agreeable tend to have lower Machiavellianism scores. So that's what the negative refers to. You will also typically report your confidence interval in the table that I'll demonstrate in a later video. So this is the 95% confidence interval around the unstandardized beta weight. The unstandardized beta is in the units of measurement, in the original units of measurement. You can't compare them to each other. We also have our T statistic. So we would report this when we report out our results in APA style. We have our p-value, which again, we would report this. And this is important. We want to look at this. We want to identify which of our predictors are significant predictors. So we can see that our first p-value that we're going to look at is agreeableness right here. So agreeableness, the p-value is very much less than 0.05. So we're going to reject the null hypothesis there that agreeableness is not a significant predictor. And so we can say that agreeableness significantly predicts Machiavellianism while controlling for the other predictor variables. So that's an important part of it. If we look at just agreeableness and just Machiavellianism, we're actually going to see a different relationship magnitude. So size of the relationship will be different. It could even be not statistically significant anymore. So the idea here is that this test is it's looking at agreeableness, but it's while accounting for or holding all of the other variables constant. So we would say agreeableness is a significant predictor while controlling for the other predictors. Neuroticism, that one here, change my color up. So neuroticism is here. That is also a significant predictor. So it is p-value of 0.02 if we were to round. And then we have gender. And we want to look at each of these. So again, these are dummy coded. We're comparing them to our reference level of male. And so we can see that our first level, female compared to male, this is saying that females are lower in Machiavellianism by negative or by 5.23 points. They're lower. That's what the negative is, right? And so this one is saying that that is a significant difference. So it is a significant predictor. However, it looks like when we compare other to male, there is not a significant difference there. Now, it's a good idea to always keep in mind the sizes of the groups that you're comparing. There's not as many people who identified as other in this data set. And so because of that, it's less likely that we'd be able to find a statistically significant difference just based on how the math works. And so it's not significant here, but that just means that we didn't find it in this sample, right? So if we had a more representative sample, we might have found something different. The last column here is the standardized beta weight, which is demonstrated with that the capital B, so the or the Greek symbol for beta. This is the standardized weight. Now, people sometimes use this and sometimes don't. I like to use it because it allows us to compare the weight of the different predictors. And so I can say which predictor seems to have the strongest relationship or the biggest effect, not causation though, has the biggest effect statistically on the outcome variable. So if I look at this, I can see that the variable that has the strongest effect is female compared to male, that 0.5, 0.60, or sorry, 0.58 if you're rounding up, right? 0.58. And so that standardized weight allows us to compare those. And so you can list them in order of their standardized estimate if you wanted to. And it just, again, it allows you a way to compare them. Whereas the unstandardized estimates, that's not necessarily going to tell you which has the strongest effect. Now, in this case, it happens to, but it's not always going to be that way. It's just that our units of measurement for agreeableness and neuroticism are similar. And so it makes it look like they're very similar. Like we can put them in order, but we cannot. We need that standardized estimate to be able to put them in order of the size of the effect. Now you'll notice that male, other to male is actually a pretty big effect here. It's just not statistically significant. So again, this is an indicator that we don't have very many people in that other group. And if we had had more people, maybe that would have been statistically significant. So that seems like that group might be a little underpowered. We didn't have enough people in that group. So one last thing that I want to include is the regression equation. And I think this helps to kind of understand what we're talking about here. So this is the slope of the line for regression. We're looking at our predicted Y, our outcome value, and our outcome variable here. So Y, this would be neuroticism, right? So we're predicting that little hat is the prediction, the prediction party hat. And so we're saying that we're predicting where neuroticism would be based on our predictors, based on our independent variables. We're not doing magic. We're not predicting the future. We're not talking about causation. We're just talking about mathematically based on the data that we have. This is how we can write this formula out. So based on our data, y hat or predicted neuroticism would be equal to the y-intercept, which is A, plus the beta weight of variable one, of our x variable one, or predictor variable one, times whatever that predictor is. And we do that same thing. So this is our second independent variable, third, fourth, and we're going to break up female and other because we dummy coded them. We created these new variables. So here, when we write this out, these are where I'm getting the numbers from. So my intercept goes there. And it's positive, so it's going to be a positive intercept. If it were negative, I would write negative 50.45. And then I'm going to do subtract, because again, it is negative. That is my beta weight, and I'm using my unstandardized beta right there, 1.35. And then let's say that I estimated, or I had somebody I wanted to know if their agreeableness was 30 I would multiply 1.35 times 30, and I would subtract that from this value here. And then if I had negative or minus 0.37, this is from neuroticism. And then whatever value somebody had for neuroticism, I would look at that value, multiply it here, and then I would just continue with this formula. Female, so if female minus this 5.23 right here, other minus this 4.97. Now, what you can do to, again, help you kind of understand this idea of when we're controlling for the other variables that I was talking about, let's say that we're calculating neuroticism and we want to look at what agreeableness is. And for this data set, agreeableness actually was maximum. It's pretty low value. So we're actually going to do, let's say 5. We'll use 5. So let's say that agreeableness is 5. And then we're going to keep the other variables constant. We're going to keep them at 0, 0, 0. So this would mean that we're looking at a male because that's our reference group for 0, right? So that crosses it out. And then we're going to say neuroticism is 0. And then agreeableness, if I multiply agreeableness by 1.35, so 5 times 1.35, what I'm going to do is I'm going to subtract 6.75 from this 50.45. Right there. And so if I do that, I get that my predicted Y, or my predicted neuroticism, would be 43.7. So I'm saying that when I'm holding those other variables constant, if agreeableness is this value, this is what I would estimate based on that line, what my neuroticism would look like for that value. So if I said, oh, somebody has agreeableness of 5, and we're gonna say their neuroticism is 0, and that they are male, so we're going to do 0 for female and other, we can calculate what we would estimate their neuroticism score to be along that linear regression. And so this is, sometimes different organizations or researchers will use this information to kind of explain this in different terms. But that's how you can use that regression equation. So that's all that I have for this video. What I'm going to do next video is I'm going to talk about writing your results in APA style. And then I'll follow that up with putting your result into an APA style table.